Welcome to the presentation of the Porto de MOS supermarket in Portugal as part of the MultiPACK project. The integrated CO2 unit was installed in Portugal in December 2018, while the data acquisition system was in operation in January 2019. These units provide cooling for the foodstuff at all the different temperature levels. In addition, domestic hot water, heating for the building, and air conditioning during the summer period. The base for this MultiPACK unit is that it is a CO2 booster system with parallel compression and expansion work recovery with the help of ejectors, both taking back vapor and liquid from the system. I will explain it in a minute. It is also intended to minimize the superheat in all evaporators. We have a heat pump function for the winter, and is a fully instrumented facility to monitor the performance. Location is in the middle of Portugal and not directly at the coast, but close to the coast. And this is a picture of the area. And the climate data for Porto de MOS show that there is a very dry summer period where the mean temperature are coming up at relatively high levels. This is a picture of the entrance for the supermarket, and the installation is characterized by the following design capacities. For the cooling temperature, for the medium temperature cooling, which means around 0 degrees, we have a 100 kilowatt installed cooling capacity. For the freezing application, it is 24 kilowatt. And for air conditioning, the building required a design of 180 kilowatt. Heating is assumed to be in the range of 160 kilowatt in the winter time, while domestic hot water can be produced with 30 kilowatt. When we look now into the P&ID of the system, we see the LT compressors on this side. Heat is rejected in a desuperheater before the LT pressured gas is injected or transported to the low pressure receiver together with the return of the empty evaporators. The empty compressors are sucking from this low pressure receiver, as also the ejectors doing in this direction. I will come back to that. So on the high pressure side, we do have a heat reclaim for hot water production, the first heat exchanger, and depending on the operation, we can send heat in the way that we send hot CO2 straight to the rooftop units in the winter period. So inside the rooftop air handling units, there are gas coolers able to reject heat into the air entering the shop. In the summer period, this three-way valve is going in the other direction, and that means heat is rejected in the external gas cooler to the ambient air. Thereafter, the CO2 downstream of the gas cooler flows through two internal heat exchangers before reaching the high pressure control devices, which are shown on the left hand side here. There is one ordinary high pressure control valve, which is just for a backup function, because the ejectors indicated with these symbols are taking care of the high pressure control. Downstream of the ejector, we have the liquid separator, where the flash gas is taken by the parallel compressors before superheated in this internal heat exchanger, entering the parallel compressors. And downstream of the liquid separator, the liquid is distributed towards the different heat exchangers in the cabinets, and we can see the LT cabinet in this part, while the empty cabinets and evaporators are in this part. So this closes the circuit. In case we need air conditioning, the rooftop units are equipped with DX evaporators, which can be operated in two modes. One mode is to bring high pressure CO2, which is cooled after the gas cooler, towards these expansion devices, evaporating the CO2 directly inside the evaporators of the air handling unit, cooling down the air, and then it is returned back to the receiver. On the other side, we are also able to maintain air conditioning by applying an ejector, which circulates the liquid from this receiver towards the evaporators, evaporating and sucking it back via the ejector to the receiver. Both modes have been tested and are successfully verified. This is a typical operating parameter where we can see the pressure level corresponding to the saturation temperature at evaporation, which is for the medium temperature level at around -3 degrees. For the low temperature freezing applications, about -29, while the pressure level in the separator is at 36 bar in this case, corresponds to 1 degree plus. Here are some pictures from the machine room on the left hand side. You can see in the back part all the compressors and the LT compressors and the medium and auxiliary air conditioning compressors, while on the narrow part we can see the high pressure control devices. You can see the ejectors, the medium temperature ejector here on top and the air conditioning ejector on the bottom part here. On the right hand side you see a picture of the outdoor heat exchanger, which is a double functional device. It has two independent coils on the air side, CO2 and air side. The 10 blowers are able to suck the air and reject the heat in the summer, but also in the winter we have a coil for evaporation, so we can extract ambient heat and bring it into the shop via the heat pump function. The lower right hand side we see the pressure switches and pressure starts as in an ordinary system. The achievement which have been demonstrated through several years now, this is an example from 2019. In that period, annually around 30,000 euro have been saved compared to the benchmark baseline system, which was a standard system by that time for the supermarket, because we are having a much more energy efficient system and we do the integration of all the functions within one unit.